Okay, on to the last bit where we're going to be installing the little servo in the front here, mounting this piece here, and of course the control rod that will link it to the servo, fitting the magnet, and then modifying the attachments so that they can be picked up and dropped off automatically. Just before I do any of that, I have created just a couple more parts on the 3D printer, and I want to install those before I lose them. The first one is a plug for this hole here, tiny dab of super glue on each side of it. Try not to get it on my fingers. That goes there. And then the other one, which actually isn't completely symmetrical, and it's probably hard to see it with the camera, but basically this top disc here is towards the back, and that will go towards the back of this lip here. I'll just put a dab of super glue there. Another one there. And that will just pop in. Okay, so that's done. I won't lose those now. Before we install the servo, there is just a little bit of trimming that needs to be done on the arm here. And if you've cut out the same as what I've done there, mark about 15mm from this edge here. So, and then about 12mm from the top. Is about there. Draw a line parallel to this pipe. And then another one vertically there. Take the 2.5mm drill and just drill roughly in the corner of the triangle you've marked out without going outside the lines really. Then using a knife, probably best with a fairly new blade, just carve inside the black lines that you've marked to the outside of the hole you just made. As ever, not pointing the blade towards you while you're doing it. Okay, something like that. If you find that that needs to be bigger later on, you can always come back to it, but that's probably about the size that we want. Then taking this piece here, the piece that mounts onto the arm there, we're going to want to make a hole in the back here, but before we do, there's a piece across here that we need to get rid of. Using a brand new blade is actually fairly easy just to chop that off. On this side here, you want to try and make sure that it's nice and smooth. I think that's okay. And then we're going to want to drill a hole in it, and the hole is going to need to be about there. So you're towards the bottom, you're definitely not in the centre, and you want to be at least, in terms of the centre of this hole, probably 3 or 4mm in from the edge, and it needs to be about there. This is quite an important hole to get right. So keep checking that you're happy with it. And this is the 1.5mm bit that I'm using. So there we have our hole. This can now be put back on the model. And you will hopefully see that the arm can actually travel quite a distance with that hole still being visible. This is going to set the maximum travel for the bucket in the tipping direction. And I think that that is probably enough. It's giving us up to sort of 90 degrees, and I think that that will be plenty. Next we should mount the servo, and I'll just post the wire through here. That's in there nicely. And then using the 2 screws that actually come with the servo, put those in the holes that we made when we were cutting out the servo hole. And then plug the servo into the plug here that we made earlier, making sure that's nicely together. Not forgetting that the white goes to the yellow, etc. I think we are going to want to use the cable tie with this hole here, just to keep this out of the way when it's moving backwards and forwards. So I'll just post this through. I think I'm going to want it to go like that. Yep, that's just where I want it. When we were programming up the transmitter, the one thing which I didn't do was set the travel on this servo to 120%. We want really as much movement as we can get, because that's going to give us a good tip on the bucket. On this mode 2 transmitter, we know that we've got the bucket on this arm here, and if you haven't discovered much about this transmitter, one of the things which I really like is the ability to see the monitor from the front screen, and you just literally just flick it across a couple of times, and we can see here, you see the bar moving. Channel 3 is the one that we're using for the bucket, so we'll just go back. Go into the main menu, set the endpoints, channel 3, one side, click over there so it's the hundreds as opposed to the units or tens, scroll it up, tick, then the other side, so 120 in each direction, go back, are you sure? Yes, and that's done. So now we have 120% movement in each direction on the servo, and that's going to give us the most movement. For the next part, we're going to want to leave the radio control switched on so that we get all of the movements properly coordinated. Turning on the model, the end that I'm going to want to really focus on most is when this is in the down position, which means the bucket's in the up position up here, because we don't want the servo binding, so we're going to want in that position this to be all the way up. The other thing that we need to take into account is that there is a mix between the arm lifting and the bucket, so it is actually this position here when the arm is at the bottom, so we just need to move the arm to the bottom as well, and that means scrolling the wheel. Let's move it here. So that means scrolling the wheel upwards that way, making sure that things don't fall over while I'm doing it. So here we have the boom at the very bottom of its travel, and we have the bucket in its furthest back position. The next thing to do is to take a piece of servo rod, and this time I'm using the softer variety that actually comes with a thread on the end of it. If I can, I'll try and find a link to these. You get them in packs of 10, I think, but this is quite a soft metal and it's quite a nice shape, and for doing this I think it's going to be better than using the piano wire that I used for the steering inside, where it was actually much easier to do. I'm going to start by putting a bend in it somewhere towards the end. Let's see how that looks. That looks fine. Because it's soft, I don't mind using these cutters. I wouldn't use them otherwise, because otherwise they'll quickly get worn. Just give that a chop, making sure that it's going to fire away from me. This should be able to worm its way into that hole. If it's proving difficult, you can always slightly enlarge it with the body reamer, but don't go too mad. Once it's been in there once, it'll be okay going forward. That isn't looking too bad. Now, because I've got the benefit of the model which I've already done, I can see that the angle that I want the servo arm to be at when it's in this position is going to be about there. But before I do, we want to enlarge the fourth hole out using the 1.5mm drill bit. So 1, 2, 3, 4. And again, the reamer might be useful just to open it up a tiny bit for the first time that we put the servo arm in. And actually it's going to be going in from the bottom, so I'll just do that side. And hopefully you can see it's about there, so it's relative to the servo, it's probably about sort of 5 o'clock. Let's push that on properly so that it clicks, so we can see where that's going to need to be. Now this rod here is going to need to make it up there and go through, and you can see that there's quite an angle involved in doing that. Plus also when the arm comes up for the tipping, we aren't going to want it to hit the servo. So I'm going to take this arm off and I'm just going to put a couple of bends in it. This is really why it's better for me to be using this softer metal, because it's much easier to do these bends. So I'm going to put a bend like that, and then a little bit further back I'm going to put a bend the other way. So we're looking like that. So let's give that a go. So we put that back in again, and that's not looking unreasonable. And then taking this and turning it round about there, I'm actually going to put a small sideways bend in it too. Which is hopefully going to allow this arm to miss the servo. When you do this, you may find that there's quite a bit of trial and error involved, and you need to go at it patiently. To be honest, when I was first setting this up, this bit alone, just getting this rod right and everything working, probably took me a couple of hours. Although that did include doing the programming, I think that that looks reasonable. Now I'm going to make a mark there with my pen, because that's where we need to come up to go through the hole. And then taking my Z bender, and looking to see where that part there of the jaw is, and I'm lining that up with my black mark, and I'm trying to keep it in the same kind of plane as this Z bend that we've got at the bottom. We'll give that a squeeze. That's looking hopeful. And then I'll chop the end there. Take off the servo arm. And then going in from underneath, that bend that we've just made, we should be able to put this in the bottom. Like so. And then put it in the bottom there. Put the servo arm back on. Okay, so we have got very slight buzzing in this position. That's not too bad. There is something that we need to do to this part here, and I'll just quickly do that. And that is to chop out some of this so that the angle of this can go further back, particularly for when you're lifting the bucket. You chop there, chop there, and chop there. That actually allows this arm to go back slightly more, making sure in particular that you haven't left any material there. Okay, so that's going back nicely. And then returning to our arm, we'll just put this back in again. And then, having just fiddled around with it for a few minutes off camera, doing a little bend here and a little bend there, we've got it to a state where we've got the arm at 5 o'clock, the servo isn't buzzing at either end of its travel, so that's all looking good. And we can just quickly test to see if the mix is actually doing the right thing. I'll just tilt the camera back slightly. So if I was just to put the forklift attachment in for a moment like so, and make it level, which is about there. I know perhaps put this on it. If I was to raise the arm using the wheel, hopefully you can see that this is remaining roughly level all of the way up and all of the way down. Okay, so that's one of the more fiddly bits of the build. You've just got to put yourself in a very patient frame of mind and just keep going until it's working properly for you. Not forgetting to put the screw in for the servo. Take this off. The next thing to do is to glue the magnet in. Get some super glue in there. Take the magnet and just pop it in. I don't think a bit of activator is going to do any harm. Okay, and that's the magnet done. In order to get the magnet to work with the bucket, the first thing to do is to chop these two tabs off, and it is exactly the same thing that you would do with the back of the piece that goes with the forklift. So if you see where those holes are, you just literally chop across so that you can't see the holes anymore. One, two. That's going to make it easy for the bucket to go on and off without catching. But if you actually want it to stay there, and particularly when you're tipping, if you don't want the bucket to fall off, you're going to need to put something else on. If you take the bucket and you look at this row of numbers across the top, roughly in the middle of the numbers, so I think that this says 1425, and I've gone underneath the number 2 and I've drilled a 2.5mm hole, probably about 16 or 17mm up from the bottom, using the 2.5mm drill bit, taking a 4mm machine bolt, get that lined up, screw it in virtually all of the way, and you'll find with your own magnet that you can actually fine tune this for the amount of grip that you've got, etc. Just pop that on there for a moment, and I can hear that the bolt is making contact with the screw, so that is good. And similarly with the piece that either holds the forks or the prongs, you want to drill a hole in this piece which is going up, probably, let's have a quick check, about 6 or 7mm up from the bottom, and the size of machine bolt that I used is about 12mm, and when that's screwed through so that we're flush here, it seems to be in about the right place. And you can hear the bolt clicking onto the magnet. Obviously this all needs testing. So we bring it down, we tilt it forward, and either driving the truck forward or indeed extending the arm, put it up a little bit, rock it back. That seems to be good. Let's put it back down again. Well, that's one. Good. Well, all of that seems to be working. If you want to use the other arrangement which I used in the running video, this set, which contains the prongs and the forks, actually comes with a winch, which is quite handy because you can plug that on the front there. Here's my little hook that's included within the 3D prints, and that just clips onto the hook, which actually comes with the winch. And then these pieces here I made so that it stands up at about the right height for the automatic attachment and release. So I'll just pop that there for a second. Move these out of the way. And then we're able to lower it, extend the arm. Need to raise it a little bit, I think. And there we have the hook for picking things up. Okay, well, I think that probably takes us to about the end of the build series. I hope you've enjoyed following this, and I hope even more that you've either had a go or you're going to have a go at building one of these things yourself. It is a very satisfying build. You need to take your time with it and you need to enjoy it, really. I've got lots more Bruders in my head that I'm going to be doing videos over into the future, but I thought I would do one in really high detail. I probably won't do them all like this, but I just wanted to do one like that because a lot of the techniques here are going to be relevant to the other models that I've either built or I'm going to build. Please feel very free to add any comments or ask any questions in the section below. And until the next time, once again, thank you very much for watching.